Hello, welcome to my channel. We have been solving these past papers. Right now, I have this mathematics, paper 1, pure math 1, and it is from uh, May, June 2025. Okay, so we have done some of the questions before. Uh, so let us go to question number 9. I believe, I think I have done 8 questions. So, yes, this is the one I want to do, question number 9. Okay, it's very interesting question. You see, there are 3 points P, Q, and R. So the coordinates of P are given, Q are given, and R is given in terms of K, right? Okay, where K is a constant. It is given that angle PRQ is a right angle. Show that one of the possibility values. Okay, we have to find the value of K, knowing that this is the right angle. Okay, let's have a rough idea what is the situation here. You see, there's 1 point minus 3 and 5. So this is P, which is, sorry, minus 13 and 5. Okay. The next question, next point, 5, 1. So 5 and 1, this is point Q. Okay. And R is 2 and K. So its X coordinate is 2, but the Y coordinate is K, which we do not know. So it's somewhere here. Okay, so point R is somewhere on this line. Its coordinates are 2 and K. Okay, and we are told that this P, R, and Q. Okay, this is a right angle. Okay, so using this information, we have to find the value of K. Okay, so there are several ways to do this thing. So let me try to find the slope of line PR. Okay, so first I will find the slope of PR. Okay, and how do we find the slope? Y2 minus y1. So y2 minus y1 over x2 minus x1. Okay, so this is k minus 5 over 15. Similarly, what is the slope of QR? Okay, Q and R. Okay, so again the same thing, y2 minus y1 over x2 minus x1. So this is k minus 5 over minus 3. Okay, so if these two lines are perpendicular to each other, then the product of this slope has to be -1, right? So it means k minus 5 over 15 times k, so this is 1, not 5, k minus 1 over minus 3. So this is equal to -1. Okay, so from here I can conclude k minus 5 into k minus 1 is equal to 45, right? 15 times 3 and with negative sign is 45. Okay, so this is going to be k square and minus 5, so minus 6k, and 5 minus 45 equals 0. So this is k square minus 6k and minus 40 equal to 0. Right? So we have this quadratic equation which we need to solve. And yes, when we try to solve this quadratic equation, uh, k equals minus b plus minus under root b square minus 4 into a, which is 1 into c, which is minus 40, and divided by 2a. Okay, so where did I solve this? Yes. Okay, so the solution of this comes out to be 10, or let me solve it. Yeah, 6 plus minus 160 plus 36. So 6. So 196 square root is, I believe it is 14, right? Over 2. So it will become 3 plus minus 7. So when we add them together, it is 10. When I subtract 3 minus 7 is minus 4. So these are the two answers, right? Uh, 10 and minus 4. Okay, so these are the two values of k which will give this angle 90 degree. There's one more approach to do this one. If this is the right angle, right, then this triangle PQR should follow the Pythagoras theorem, right? So you can apply this, you can find this distance PR and then make it square and then RQ and make it square, and that should be equal to the PQ distance square. So that's another way to solve this and you will get the same answer. Okay. Um, okay, so this is part A. Let me move on to part B. It is now given that K is 10. Okay, so out of these two values, they are choosing 10. Okay. A circle passes through point P, Q, and R. Okay, let me do it again. Once again, it's a little bit uh, time consuming, but it is worth it. Okay, so one point is minus 3, 5. Am I right? Minus 3 and 5, yes. Not minus 13. Minus 13 and 5. This is point P. And then point Q is 5 and 1. Somewhere here. So this is Q, which is 5 and 1. And point R is known as 2 and 10, right? So this is point R, which is 2 and 10. Okay, so these are the 3 points. And we know that the line joining these, it is a right angle here, right? Okay, now find the equation of the tangent to the circle, assuming that there's a circle passing through PQR, right? And tangent to the circle at R. So we have to find the equation of the tangent to the circle at R. Okay, there's one thing I hope you guys know this thing, that if I talk about semicircle, right? This is the diameter of the circle. So if on a semicircle you have any point, then this angle is going to be right angle. This angle is going to be right angle. So if you have any a point anywhere on this semicircle, this angle is going to be a right angle. Okay, so if it is a right angle, so there's a circle passing through these 3 points, 1, 2, and these 3 points, the circle is passing like this, right? And if it is a right angle, then I conclude that the center of the circle is over here, right? So I can find the center of this circle by the midpoint of P and Q, okay? So center of circle I can find by the midpoint of P and Q. So this is uh, 5 minus 13 over 2 and sorry, yeah, no, 13 and 5 and 5 plus 1 over 2. Okay, so 5 minus 13 is minus 8 over 4. This is minus 4 and 6 over 2 is 3. Okay, so minus 4, 3 is the center of the circle. Okay, so now I need to find the equation of the tangent to the circle at R, this line, right? So of course, this line, this tangent line, it will be perpendicular to this radius, right? If I call the center point as C, then CR point, CR line, it is perpendicular to the tangent line. Okay, so let me find the CR. Okay, slope of CR. Okay, how do we find it? Y2 minus Y1 over X2 minus X1. So 10 minus 3 is 7 over 6. Okay, so this is the slope of this line CR. So slope of the tangent line, slope of tangent line, it is going to be the negative reciprocal of this, so this is 6 over 7 and negative. Okay, okay. Now this tangent line, we need to find out, it has this slope and it is passing through this point. So now to find the equation of this straight line is easy. in this type of thing, we do the y2 minus y1 equals m times x2 minus x1. So y2, no, sorry, I should not do this one. I should just say y1 and this is y. And this is x1 minus x. Let me write it right again. So y1 minus y equals m times x1 minus x. Okay. So what is x1 by 1? This is this point, and m is the slope, and you can find the equation. Okay, so y1 minus y, or it could be y minus y1 as well, equals m minus 6 over 7 into x1 minus x. Okay, so I can simplify this thing. If I multiply everything by 7, it will be 70 minus 7y equals minus 12, and minus minus plus 6x. Okay, if I bring everything on the one side, so 6x plus 7y and minus 12 and minus 70 equals 0, right? So this will give you 6x plus 7y and minus 82 equals 0. Okay, so this is the equation of the straight line which is tangent to the circle and at R. Okay, I hope this question is clear. Now let's move on to question number 10. Okay, a curve C has this equation. Okay, find the coordinates of the two stationary points. Stationary points mean the points which are either maximum or the minimum, right? So, and we can find them by equating the derivative to 0. Right? So I will write this expression this way, that y is equal to 9 and 2x minus 5 power minus 1 and plus 2x minus 5. We can put it. Okay, so what is dy by dx, the derivative of this curve or this function, is going to be minus 1 times 9 is minus 9 and 2x minus 5 power minus 2, and the derivative of this term is 2 and plus 2 only, right? So I can simplify it a little bit. It is going to be 2, write this one first, and minus 18 over 2x minus 5 power 2. Okay, so this is the derivative. And in order to find the stationary point, we will put it equal to 0. And when we put it equal to 0, then you can see this 2 is equal to 18 over 2x minus 5, and it's square. So from here, I can see that 2x minus 5 and its square is equal to 18 over 2, which is 9, right? So if I can get the square root on both sides, so 2x minus 5 is equal to plus minus 3, right? So 2x minus 5 is either equal to 3 or 2x minus 5 is minus 3. So from here, 2x is equal to 5 plus 3, 8, and x is equal to 4. And from here, 2x is equal to 5 minus 3 is 2, and x is equal to 1. So the two answers we get is 1 and 4. So when x is 1 and x is 4, that is where we have the stationary point. Okay, now if x is 1, what's the value of y? Y is going to be, substitute x equal to 1. So 2 times 1 is 2, minus 5 is minus 3. Get it? And plus 2 times 1 is 2, minus 5 is minus 3. So this is minus 3, minus 3, so answer is minus 6. Okay, so one stationary point is 1 and minus 6. And second stationary point when x is equal to 4, right? So if x is equal to 4, y is going to be equal to 9 over 8 minus 5 is 3. Okay, and plus 8 minus 5 is 3. So again, this is 3 plus 3. So this is equal to 6. It means the second stationary point is 4 and 6. Okay, so these are the two stationary points, or one. I mean, they can be either maximum or minimum. Okay, so we will leave it here. Next part is find the second derivative and hence determine the nature of the each stationary point. Okay, interesting. So now we know that dy by dx, in the first derivative, we found this thing as 2 minus 18 over 2x minus 5 and its square. Let me write it as 2 minus 18 into 2x minus 5 power minus 2. So when I differentiate it second time, second derivative d square y by dx square is equal to, this will be 0 and minus 18 times minus 2, okay, and then 2x minus 5 power minus 3, and the derivative of this thing is 2. So it is going to be mm, 18 times 4. How much is this? Now, this is 72. Am I right? 72 over 2x minus 5 power 3. Okay. Let's make sure. Yeah. Okay. Now, we determine the nature of the stationary point. So nature means that, okay, we found these two stationary points. Remember this one and this one. So now we say that, okay, being stationary means that either it is maximum or minimum. So, but now we have to find out whether it is maximum or minimum, right? Okay, so at this point, I will try to know the sign of this second derivative. Okay, so I want to find second derivative d square y by dx square when x is 1. Okay, for this first stationary point. Okay, so when x is 1, this is going to be 72 over x is 1, so 2 minus 5 is minus 3, and minus 6 cube is minus 3, and it's q, right? So it's a negative quantity, right? I don't need to know the exact answer, but I need to find the sign. So this is a negative quantity, this is less than 0, right? Okay, and you should know that when the second derivative is negative, that point, that stationary point corresponds to the maximum. So this point is max point. Okay, and I hope you know the logic, but let me explain this quickly. Where should I sketch it? Okay, you see, if I have a curve which is maximum at some point, right? So here the slope is positive, here the slope is 0, here the slope is negative. So how the slope is changing? It is becoming less and less, right? So that's why the second derivative, which is the derivative or the reduction of the slope, it is negative. Okay, so whenever the slope or the second derivative is negative, then this corresponds to maximum point. Okay, now let's calculate the second derivative, d square y by dx square when x is 4. Okay, the second stationary point was when x is 4. Okay, so what is this? It is 72 over 8 minus 5 is 3. So this is 3 power 3. So again, this is a positive quantity, which means it is a minimum point. Okay, and again, let me explain. If we have a minimum point, right? So the slope here was negative, slope here is 0, and slope here is positive. So as x is increasing, slope is increasing, right? Since slope is increasing, the second derivative is increasing. It's positive. That's why it's a minimum point. Okay. I hope you understand the logic and what is the answer. How do you find the answer? Okay. Now the curve says, okay. Now this is a very interesting curve. You see, uh, we just found that the two stationary points They are 1 and minus 6, almost here, and 4 and 6, right? This point is 1 and minus 6, and the other point is 4 and 6, right? But this is the maximum point, this is the minimum point, okay? So it is something like this, and this is something like this, okay? So I don't need to explain, but when x is 2.5, there's an asymptote here, okay? So don't worry about this. We are not talking about this particular thing. So when x is 2.5, because you see when x is 2.5, this become infinity or undefined, I should say, right? When x is 2.5, so 2.5 times 2 is 5, 5 minus 5 is 0. So this become 9 over 0, so it become infinity, right? Or undefined, as I said. So that's why, but interestingly, this point is minimum and this point is maximum. Okay, now this was curve C, right? Now a new curve C1 is formed by this translation, which means that x is moved -3 and y is moved 7. Okay, so let's see. When x is moved -3, so this coordinate will come negative and 7. Okay, so it's somewhere over here. Okay, this point will come over here. And so what is the new coordinates of this point? This 1 minus 3 is going to be -2, and -6 plus 7 is 1. Okay. Similarly, this point, it will be somewhere over here, and the coordinates are 4 minus 3 is 1, and 6 plus 7 is 13. Okay, so when we move this translation, this new stationary points are -2, 1, and 1, 13. Okay, and then there's the followed by a reflection in x-axis. Okay, so when we do the reflection in x-axis, so this will come over here, right? And it will become 1 and -13. And this point will be somewhere over here, which is -2 and -1. Okay, I hope it's clear that when I take the reflection of this curve in x-axis, I will get these 2 points, right? Now the question is, state the coordinates of the maximum point of C1. Okay, so of course the maximum point of C, this is my curve C1. Okay, this was C and this is C1. So the maximum point is 1 and -13. Okay, this is the maximum point of the curve C1. Okay, I hope it's clear. Now, find the equation of C1 in this form. And I will, this is the last part. Okay, yeah, good. Okay, so you remember the equation of C. Let me write it again. So equation of C, it was y equals 9 over 2x minus 5 plus 2x minus 5. Okay, so the curve equation for the C1 curve, okay, you see x is moved to -3. So that I can show by putting for every x, I will put, since it's moving x negative, I will put x plus 3. Okay, if I replace x with x plus 3, that means I have moved this curve to the left by 3 units and -5. So I will just replace every x by x plus 3. So what have I done? I have moved this curve to the left by 3 units. Now I have to move it up by 7 units. So I will just add 7 into it. So it will go up, right? And the third thing is that I have to take its reflection in x-axis. So I will multiply everything by -1, or just take the negative of it. So this would be y equal to this thing. Okay, I hope I'm not confusing you. So anyway, let me simplify this situation. Y equals negative, let me leave it outside, 9 divided by 2x plus 6 minus 5 plus 2x plus 6 minus 5 plus 7. Okay, so 9 over 2x, or 6 minus 5 is 1. Okay, and plus 2x, and 6 minus 5 is 1, plus 7 is 8, plus 8. So this is the new equation of our curve C1. So y is equal to negative 9 over 2x plus 1, and negative 2x and negative 8. Okay, so this is the equation of the curve C1. Okay, I hope it's clear. So anyway, you can see that A is negative 9, and B is 2, and C is 1, and again D is minus 2, and E is minus 8. Okay, I hope everything is clear. If you ever have any question, you can always ask me in the comment section. And if you find these videos useful, then please subscribe my channel. Thank you for watching. See you in the next video.